Hello again, this is Point on Pally, and in this video we're going to go over how to build a coiling setup for like a tentacle or a tail or something to that effect. And what we're trying to get is this kind of motion here, the ability to coil the tentacle up or roll it up into a tight ball, like quite like this. Um, I'm going to show you two different types of setups to do this effect with. One is kind of the standard method, and the other one is kind of one I came up with in a different video that I will show you how to do here. Um, so this video is loosely based off of one I just did for my other video series, making a character rig. And in that video series, we go through the process of building an entire rig. And the character I use has a number of tentacles on him, and I'm currently in the process of setting up the tentacles for that, and I came up with this method for coiling the tentacle because the default method, which I will show you here, didn't really work for what I needed. So I'm going to open up a default file here. So what I have visible to you right now is what we're going to use the default setup on. So currently I have a kind of a tail or a tentacle here. I just called it tail. And it's set up with a ribbon rig. So I have a ribbon here, a NURBS plane with a bunch of joints attached to the follicles of that NURBS plane, and those joints control the geometry here. And I find that the coiling effect is typically used a lot with this type of setup with a ribbon, because ribbons are very handy because they can control any sort of kind of tail or tentacle object, and you can create blend shapes for the ribbon on top of the existing rig that's already there, and you can put a bunch of different types of deformers or rigs on those blend shapes, and so you can have a bunch of different types of animations or deformations all on one rig together. So it's really handy. So we're going to use this setup to kind of show how to create the coiling motion. So this is kind of the default setup that we're going to use. So I'm going to just duplicate the geometry here. Bring this to, let's say, 5 here. Now the default setup for doing a coiling effect is pretty basic. All we really need to do is go to Deform, Nonlinear, Bend. So we're given this bend deformer here. Now what I'm going to do is I'm going to rotate it into position, and I'm going to curve it just to see. Okay, good. So it's on the right axis that I want. Now the first thing I'm going to do is cut off the curvature on the left side of the tail. So I'm going to do that by zeroing out the low bound here. So now you can see it's just affecting one side. Now I'm going to take that curvature and I'm going to throw it all the way to negative 180. Now you'll notice that after 180 you see that it stops. Now and that's because you'll notice that the deformer only goes to it goes to 180 degrees, and then it pretty much stops at that point. So it just keeps going straight once it gets beyond the 180 degree curvature. So the way we get it to curve all the way around is we up the high bound number here. So I'm just going to up it to 10 because that's the max number. So basically that'll mean 5 full revolutions, or 5 times around on the curvature, which should be enough here. And now I'm going to scale it down a little bit. Now, depending on kind of the width of the tail or tentacle or whatever you're going to set this up with, that's going to determine the scale of the handle here. So the real way to test this, to see if it's actually working, I'm going to move it to the side here where it's not affecting the geometry, is I'm going to apply this as a blend shape to the original ribbon geometry there. So I'm going to go to blend shape. We'll just call this tail thin shape, and we'll create. So I'm going to turn this on to 1 and keep it on. So now, if I move this, you're going to see it's affecting that. Don't mind those joints, they're for the other setup there. So we can just hide those. These joints are the ones that are controlling the geometry here. What you'll notice, as I move this, you see it's now working, now getting that curvature. So you can already see we can probably scale this down a little bit so that we can get a little bit more of a kind of a thinner coil here. Now you'll also notice, as I move this around, that it's curving in on itself, that it's collapsing into itself. So how do we get it so that the curvature kind of offsets a little bit and it curves in a coiling fashion, like it's constantly expanding? Well, the way you do that is pretty easy. I'll curve it just a little bit so you can see it. We just take the handle here and we rotate it. Just ever so slightly. Just like that. And again, depending on the width of the geometry here, will determine how much you need to rotate. But just a little rotation, just like that. And now we can just take the translate X here and just drag it. So now you can see. Now, obviously, that coil's not looking, it's a little tight there. So we can probably do is adjust the rotation a little bit. You know, I could probably scale this up. You can even translate a little bit to widen it out. Let's see. Maybe something like that. Let's take a look. So looking pretty good there. Now we can keep adjusting some of these settings here. We can lift it up a little bit to kind of widen it. We can adjust the rotation value, but I actually like where it is. We can scale it out a little bit, something like that. There we go. So at this point, we got the settings pretty much where we want them. And you can see we're getting a decent coil here. Now there's a few things that I don't really like about this setup. The first thing is you can see it's not a very tight coil in here. And it tightens up the further it goes, but it doesn't really tighten up. It's not really natural here. It's a little loose and then it tightens up as it rolls along, which I'm not really a huge fan of. The other thing that's a problem with this setup is this only really works if the width of the tail or tentacle or whatever you're rigging is the same throughout. If the width of the object like it varies or it changes as it goes, then this setup will not work because how it curls here might be different from how it curls over here, and the width is really going to determine what setup you use for the coiling setup. But this is the basic one here. At this point, you can just use the set driven key to move the translate X of this if you want to get that set up. So This is pretty much the basic setup here, but again, there's a couple of problems that I don't really like about this setup. And as I was messing around in the other video, I kind of came across a new method that I want to show you guys here. And I'm going to show you this is the other kind of tentacle tail setup I have here. And now you'll notice this is loosely based off of the geometry of the model I'm currently rigging in my other video. And you can notice that the width of the tentacle starts to increase the further down it gets. So closer to the root of the tail here, it gets much wider. And the nonlinear deformer setup for the nonlinear bend setup, that's not really going to work here. It'll coil fine here, but the wider the tentacle gets, the more it's going to collapse in on itself to the point where it's going to look very rough over here. So we're going to do a different type of setup. And this setup is pretty basic. All we're going to do is use an FK joint system, and we're going to do a node setup that we create with a script. And that's really all we're doing here. So I'm going to start. This is a very similar setup with the ribbon. It's just joints attached to a NURBS plane, and those joints control the geometry here. So we've got the ribbon here. I'm just going to set this to 5. And we're going to create a joint system for this ribbon. So use the joint tool here, and I'm going to vert snap to each edge loop. So we should have 20 joints here. Snapping to every single edge loop, but we should have 21 joints, I believe. This is that end joint. Yep, 21 joints. All right, so I'm going to move these into the middle. Since I moved the ribbon to 5 in Translate Z, I should be able to move this to 5 in Translate Z as well, and there it is, nice and centered. Next, I'm going to name these joints. I'm going to use the handy dandy tool here so it doesn't take too much time. So I'm just going to call this CT tail wide. Naming. Now by default, my tool has these joints set to bind for the suffix. I'm actually going to set these to waist because I only like bind joints to be the ones that affect the main geometry there. So I'm just going to quick search and replace the names with waist. So that should do it. And I'll make sure to name this last one waist as well. Okay, so we've got the joints named. Next, we're just going to do a default bind on this duplicate ribbon here. So I'm going to select all the binding joints. I'm not going to include that end one there. I'm just going to select the 20 here. Shift click the geometry, skin, bind skin. We're just going to use default settings here. Next, I'm going to apply this as a blend shape to the original. So go to Form, Blend Shape. We'll call this tail wide V-shape. Create. And make sure you turn that on. Alright, so if I select these joints, it should be affecting the geometry. Just make sure. Very good. Alright, so at this point, we can bring in our script. So the script down here, it's kind of in a rough state here. I haven't added a GUI or anything to it. It is just kind of a little primitive here, but gets the job done. I'll explain what each part of this script is doing. So, didn't mean to do that. Okay. So what the script is doing, if I bring it up here. So I got the idea for the script from a different script I used for my sticky lip setup. If you're familiar with my channel, I have a few videos on doing a sticky lips rig. And in there, what I did is I converted a 0 to 10 attribute and divided it up based on the number of CVs on a curve. And once that incremental value is reached on the attribute, it would activate a blend shape on the curve, thus creating the sticky lips animation. So what I decided to do is take that concept and apply it here. So what it's doing is this script is taking an attribute that I create here and dividing it up based on the number of joints in this little setup here and creating an incremental value. And when the attribute that's going to be on this control here reaches that incremental value, it'll start to activate a rotation on the joint. And so the joints will progressively start to curl as it goes along. And the values of the joints we kind of set ourselves, the value of the rotations of the joints. So here's the script. So what this is doing, I'm just getting selected variables here. So this is set up by selecting the control first. That's how we get selected 0. Then I select the root joint of the system, and this will give me the remaining joints of the system. This gets me the length of the number of joints. I subtract 1 because it accounts for that waist joint or the end joint here that doesn't affect the geometry at all. This creates the attributes I need for the main kind of animations for the coiling. This is going to coil up and down, so in the z-axis it's going to coil side to side, and this attribute is going to turn the coil, so it's going to rotate the x-axis. So what's happening here is I decided I like the option better of actually having an attribute for the rotation of every joint in this system. The reason for that is that you can adjust it as you see fit. So we have like a set default value, but you can adjust the values depending on the width of the tail or the tentacle. So what this is doing is this is creating each attribute and applying kind of a default value. Essentially, it starts at 80-degree rotations, and then it divides it by, or then it subtracts an incremental value and applies that to the next rotation value, kind of thing. So this creates those attributes and applies the default value. Then this math right here, this takes a 0 to 10 attribute and divides it based on the number of joints. This is that incremental value I was talking about. And the half value I'll explain when we get to that. So here is the nuts and bolts of the setup. This creates a series of set ranges and plus minus average nodes. I plug the attributes for the up-down roll and the side-to-side roll to the set range, and I set the old min and max to the default values of the attribute. So so it's 0 to 10 for the positive rotations, and it's negative 10 to 0 for the negative rotations, because each of these attributes is going to go negative 10 to 10. So this if statement right here, what this is doing is this is where that half value attribute is coming in. So when I first set this up, I just had it, once it reached the incremental value, it would rotate, and then we'll go to the next one, it would rotate. And the problem is it was a little clunky. It would hit a bump once it reached its max rotation. So this would rotate all the way, and then it would kind of like stutter a little bit, and then the next one would go and it would stutter, and it would appear blocky. So what I opted to do here is say if it's starting at 0, then just add the incremental value. Essentially, that's what the counter is for. But if it's not at 0, set the beginning rotation to be half an incremental value back. So as this joint rotates, once it reaches halfway, then the next joint rotates until this one reaches halfway, and then the next one rotates. So you get a little bit more of a smoother transition with the rotates. This sets the new min and max of the set range to 0. This creates a multiply divide node. So what this is doing is this is just going to multiply the attribute, or this is going to apply a negative multiplication to the rotation value. So like if the rotation value is 60, it's going to be negative 60, so that it goes the other way. It can coil in the other direction. So that's what all this is here. This is just plugging it into so what this is doing is those individual attributes I created, they now get plugged into the set ranges as the rotation value. And here, this plugs them into the plus minus average so that both rotations can be kind of combined into one kind of rotation value. So they can be added together. And then this just creates an additional set range so that I can control rotate the coil in the X degree. So that's really all this is doing here. So with that, we're going to run the script now. So I'm going to select the icon and then the joint in that order. And we're going to run the script. All right. So the first thing you're going to see here, I'm going to just lock and hide stuff here. So the first thing you're going to see is the roll up down, the main icons here. Now you see if I rotate this, you see we get a very similar effect to the basic setup here, but you'll notice the coil starts a lot tighter here than it did on the other setup, and you'll notice that the rotation is getting less and less as it's going. Now it's still intersecting a little bit, but that's because we're just using a default set of values here. So the default set of values, I started at 80 because that was kind of the number that worked for me, and then I just increment down until I get to about 18 degrees there. So I'll show you the node network a little bit here so you can see kind of what's happening. And then I just explained it in the script, but you should be able to see what's going on here. So we have the set range here. That is controlling the rotations here. If I open all of this up real quick. So the main attributes here are plugging into the set range, which plugs into the plus minus average. That adds everything together, and then that is plugged into the rotation values. And you see we got the multiply divide here, so we can multiply stuff by -1 for the negative coiling effect. And that's pretty much it. this setup is, so we have the setup for every single joint in the system, and that's what's giving us the setup that we want. So you'll notice that we're getting a little bit of intersecting geometry here, and that is what I created these attributes for. So I can say, all right, it's already intersecting a little too much right there. So what I can do is I can grab like a set of these attributes here, and I can drag them out and decrease them a little bit. What I can do is go a little bit further into here, and I can grab a large set of these attributes and drag them out a little bit. So I can take these here, select these, and drag them out a little bit as well. Take these. What I can do is actually select a large set of them. In fact, I could select the whole thing if I wanted to. Drag it out a little bit. I might keep the rotation of this a little bit. I might keep that at 80. And adjust these a little bit. Go a little bit lower here. That's looking better. So we've reached the max coiling here, but I can adjust some of these all the way down to the bottom there. There we go. Put that up a little bit. There we go. Bring it around like that. So we're getting a much tighter coiling of the tentacle, and we're getting different settings for each one. And at this point, if you wanted to, you could actually just lock and hide these, and those settings are set. And so you don't have to worry about it anymore. And you can get the coiling effect on both the positive and the negative. So this is definitely something that the basic setup couldn't do. And you also have the option to do it side to side as well. So similar thing. Now granted, this was pretty even all the way around, so I could adjust the settings in the same way and just use the same numbers. But let's just say it wasn't as wide side to side as it was top to bottom. So you can make adjustments there if you need to. Drag this, shift click, grab the rest of these, something like that. Grab these attributes. There we go. Something like that. And then we can lock and hide these. And there you go. So now you've got a side-to-side coil as well as a top-down coil, or a top and bottom coil. And the nice thing is this turn coil, you see here, is I can turn the coil a little bit, just to give it a little extra level of animation there. And that works on both the top to bottom as well as the side to side. So that is the kind of new coiling method that I figured out here. I'll leave the script up here towards the end. And I'll post the script either in the comments or I'll post a GitHub link, depending on what's easier. But I like this setup a lot more. It's a lot more adjustable. It works with different types of setups. Whereas the basic setup really only works with like one type of geometry, like the same thickness all the way around from beginning to end. And whereas this setup can be used, and it doesn't have to be used on a ribbon. This could be used on just any like a basic joint setup. You could do that the same way. So this method is a lot more adjustable, and and can be customized. And you can use this on a control setup. You can alter the code around to do it that way. This is kind of you can do whatever you want with this type of setup. But I kind of came across this uh, just figuring something out, and I wanted to share it with you guys. And I didn't want it to kind of get lost in the large videos that I'm doing for my other series. I want to kind of put it on its own separate video. So enjoy, and as always, if you like the video and you like the channel, please like, subscribe. Let's keep the channel going. Thank you guys.